Good morning, viewers. I welcome you to today's numeracy session with Innocent Anokhaoya. The last time we met, I remember we talked about difference of two squares, which I believe you all must have practiced extensively. Today I bring to you yet another simple concept called standard form. The question now is, what is standard form? Standard form refers to an expression written in the form a times 10 raised to power n, where a means numbers between 0 and 10, while n refers to integers. Numbers between 0 and 10 are numbers like 1, 2, 3, 4 through 9. These numbers are significant numbers, while those of n, which I referred to as integers. By integers, we'll talk about whole numbers. They can either be positive or negative. Example, -1 or +1, where -1 is negative integer or negative whole number, and +1 is positive whole numbers or positive integers. Now, before we move on, we need to understand that numbers can be presented or given in large form, such that trying to manipulate such numbers become very difficult. Standard form is a topic that will help compress some of these numbers, as you are going to see it being talked about, and at the end of the day, you will see why it is important to embrace standard form as well. I give you an example. Writing numbers in standard forms. Examples. Write the following numbers in standard forms. 1, 3, 2, 3, 4. These are numbers, odd ordinary numbers. Number 1, number 2, number 3, and number 4. Now, to be able to express each of these in standard form, we should be mindful of the definition, as that is what to give us direction. Let's fall back to the definition. It says it's an expression written in the form a times 10 raised to power n. And from the same definition, we were told that a refers to those numbers, significant numbers now, between 0 and 10. And I remember mentioning each of those numbers, 1 through 9. Good. So in this case, to be able to get to express a according to the definition, which we'll be talking about numbers between 0 and 10, 3 becomes the very first number, significant number in this given set of numbers. So we have 3. Then we have to separate this expression with a decimal point, and you write out the rest numbers, which are 0, 6, 4, and 3. So in this context, we are referring to a, where 3 is that first significant digit as referred to by the definition. Then times, according to the definition, 10 by 10. You now want to consider the number of tens you have moved to be able to achieve 3.0643. By that, you check the number of tens you moved from where the decimal point is initially located, which is after 3. So if you move that, you'll be having 1, 2, 3, 4, which means you have moved 10 in 4 places to be able to get your decimal point to where it is now. So that is what is referred to as the integer according to the definition. This time around, it's going to be positive. Why? Because you are moving your point, or rather your 10, from the right side of your expression. We shall talk about that. So in that case, our n becomes plus 4, where 4 or plus 4 means positive integers or positive whole number, and 3 points, perhaps the other expressions, refers to a. That way, 3.0643 talks about a, 10 refers to the 10, of course, and then plus 4 talks about our n. That way, we have succeeded in expressing 30643 in standard form. Similarly, if you go to question 2, where you were given 30.6, the first significant digit here will be 3. Then that is taken note of, and immediately you separate that with a decimal point, and then you express the rest numbers out to address a from the definition. Then you bring in your multiplication sign. Bring in your 10 according to the definition. Then you check the number of tens you moved again to be able to get your decimal point to the spot it is now. And if you check from the question, you have moved once. Still moving from the right hand side. Now, by that, it means your integer will be positive as well. So you have plus 1. Now let's go to example 3. Example 3, we have 0.00452. Now, looking at this set of numbers, the first number we can have here, according to the definition, that says you must consider your A as numbers between 0 and 10. Looking at this, 4 becomes the number you can have, as those zeros are not significant in this context according to the definition. So 4 becomes the digit you will hold on to be able to address the definition. So 4 becomes, and of course, you will bring in your decimal point, express the rest out, 52, then times you now consider the number of tens you will be moving to get your decimal point to where we have it. Now, having said that, you fall back to your question. Now, check out the position you are moving your decimal point from. You would have observed that your decimal point is moving from the left hand side. And that way, you'll be having 1, 2, and 3. Which means the fact that you have moved from the negative side means your integer becomes negative, minus 3. Minus 3. Now, number 4, we are only given 9. And according to the definition still, it says A times 10 raised to power n. 9 given to us as an example, it becomes the first significant digit to be considered as it has fallen between 0 and 10. So you have 9. If you choose to put your decimal point, fine. Otherwise, you leave it. Fine. Having said that, would you say this is standard form? No. It is still ordinary form. It becomes standard form. Immediately you bring in the other part of the definition that says times 10 raised to power. What do you think this will be? It becomes 0. Why? Because you have not moved from any point. Now, by this 10 raised to power 0, it means 1. According to one of the laws of indices, we shall get there. We shall get there. So by 10 raised to power 0, which is 1, if you multiply that 1 by 9, it brings you back to the question, which means you have not affected the question in any way. Now, in the previous explanation, I mentioned that if you move your decimal point from the right, at a point I said you move your decimal point from the left. Now, that is happening because from the concept of our directed numbers, for those of us who are conversant with that, we all know that on our line graph, or the line graph is a graph showing some numbers on it, some negative, some positive, starting from the center point called 0 or origin. Now, to the right is usually positive, while to the left are negatives. So, having said that, it is what is acting out also in the explanation to why moving your decimal point from the right is seen positive in the aspect of our integers. And then when we move from example 3 we move from the left, we had our integer reflecting negative. So with that, we have succeeded in expressing each of the given questions in standard form. Okay, so now we